This is a demonstration on how to use the Land Image Analyst Minimum Distance Classifier. This is the window you'll get when you first open the software. You have the opportunity to log in. You don't necessarily need to log in if you're not going to be using classifiers, but we will be. So let's go ahead and log in. Okay. Now, let's create a new project file. So clicking Project, New Project, and we won't call it default project, but for lack of any better imagination, I'm just going to call it Demo 1 MDC Minimum Distance Classifier. Now the first thing we need to do is add the image that's going to be participating in our classification. We're using the NAIP 2016 image, and we want to create the default output datasets. Now we click OK, and you'll see we have the NAIP image clipped to the historic district of Cape Charles, Virginia. We can explore our datasets over here by clicking on the dataset panel. And since NAIP is a 4-band image, let's take advantage of that and use that band 4. And we'll look at this as a color infrared. Also, I found that adjusting the green here can help me differentiate in the trees. Let's take it to the extreme so you see what happens. I found just a little bit helps. You can see, interestingly, the healthier grass and the more bare ground. And so click OK. Okay, now the first thing we need to do to use the minimum distance classifier is to create training polygons. And we'll draw polygons over the features we want to capture. That's going to tell Leah which ones look like, in this case, tree canopy. So we'll use our default vector data set that was created when we opened. That's just this polygon. Let's just go ahead and turn these guys off. We don't need them. And we're going to zoom in and use our Add New Polygon feature tool. Since this is the layer highlighted, that is going to be the destination for this tool. If we double click here, we get the opportunity to name it. Or we can right click, Finish New Feature, and name it that way. Now let's quickly, and this is ugly, I'm going to do this fast just so you can see it's relatively quick to get a decent canopy layer using Leah. The more training sites you use, the more accuracy you'll get. I'm staying in here, the downtown area, because this is our problem area. This is the area that we want to map. We don't necessarily need to go out here and map these forests. I'll show you in a minute. We're going to have an area of interest polygon that limits it just to this area. So we need to have a good few to get a good sampling of the pixels, and we want to get as many of the different colors as we can. Notice these are quite different. The different kinds of trees as we can to participate, because right now all we're interested in is canopy type or not. Let's see, that's even hard to tell. Okay, I think we have enough. Let's zoom out. Now, as I said, we want an area of interest polygon. We could draw that polygon, but we're going to generate statistics for this as well, so we'll want to have a meaningful boundary that constrains those statistics. So I'm going to add a data set. I've already created a data layer called area of interest, and if I turn off the NAIP you can see it better. This is the watersheds that drain into this historic district. Now let's open up our toolbox and we're going to get our select tool. We can turn off the area of interest because we don't want it to be selected as a training site, and I have only those polygons that are used as the training sites selected. Now let's select those, and I should turn this off so you can see the difference. If they're not selected, they're white. If they are selected, they become, if they're not selected, they're yellow. If they're selected, they turn white. Now let's go to the minimum distance classifier tool. Tell it we're going to be looking at these as forest. We can always change that name later. It's just tree cover. We're going to be using the raster is our NAIP, and we're going to be using all 4 bands. Our output is our default classified image, and now we simply click train, and it goes through and it trained those sites. You see how they've turned green for forest. That's the color that corresponds with forest. We can see that here, by the way, and even edit these values if we wanted to. So I could change that here, but I'm happy with forest. So we've set train. Now let's go ahead and turn off those training sites because we don't really need to look at them, and we're going to click on this AOI polygon. Now, oops, I need to make sure that's forest. Let's click on this yellow AOI polygon, and it identifies everything that looks similar to the pixels that we've highlighted. So a very cool tool in Leah is this threshold tool. We can move the threshold up so it selects, it's going to select everything that's green there, and we scale it down. This is tricky. This takes a little visual sensitivity, but it's a super cool tool that allows you to either overestimate slightly or underestimate your targeted feature. Now remember, we didn't use very many training sites, so we could have better results with more training sites. Now, to make this permanent, to write it to our classified TIFF, we set our output raster, and then we simply click classify. If we had done any work before, we could say overwrite. Now let's click away. You'll notice the color will change just a little bit, and just to confirm that it's inside the TIFF, if I turn that TIFF off, you can see that it's turned off. Now we have basically a tree canopy map, tree canopy only, of the downtown area, and we'd like to get a % tree canopy for that area of interest. So I have it turned on and highlighted. Now we're going to go down here to feature operations and compute feature statistics. So our source layer is that classified image. Our output layer, that's the area of interest, that's the area that's going to be measured, and we'll set an output file name, and let's go ahead and put it inside here, and I'm going to say this, call this tree canopy, or just TC. Now we simply click apply. My fault, lesson learned. Let's click that AOI polygon and now say apply. Okay, and it came up underneath, and it shows us the percentage forest is 12%. And that is relatively accurate from other classifications that I've done and spent a little more time on. So there you go. We've created the training sites, then we've used the minimum distance classifier to create a tree canopy layer, and we've generated statistics that shows us the tree canopy is about 12.3%.